So here we're doing differentiation of natural logs. Just accept it as being a function. We worked a little bit with logs last year, probably not natural logs as such, but certainly logs. The key thing is that when you've got a natural log, when you differentiate it, it becomes 1 over x, and that'll give you the gradient function of the gradient formula to find the gradient at a particular point. So if ln of x becomes 1 over x, we use the inside rule, out rule as we did before. So for example, this one here, we've got 5x. So differentiate the middle bit. So we've got dy by dx. So differentiate the middle bit, that becomes 5. Now log x becomes 1 over x. So log of 5x, when we differentiate it, becomes 1 over whatever our bracket is. So it's 5x. And if we look at that, that becomes 5 over 5x. The 5's cancel out, and we end up with 1 over x. If we go to this one, this is called log e, which is the same as ln. Okay, it's exactly the same. Now we do the same, take the brackets, differentiate. So that becomes 2x. Now remember, log differentiates to get 1 over x. In this case, our bracket's x squared, so it becomes 1 over x squared. Combine it together, 2x times 1 equals 2x. And you can see here that that x will cancel with that x there, and we end up with 2 over x. Right, so the next one is about as complicated as you get it, because we've got brackets inside brackets. So let's remove that bit inside the brackets first. And we've got 4x minus 1 to the power of a half. So let's just look at differentiating that bit first. So again, we've got brackets, so differentiate the middle bit here. So 4x minus 1 becomes 4, times by a half, comes down the front. Leave the 4x minus 1 in your brackets, just the inside out rule. A half minus 1 is negative a half. So we can tidy that up. 4 times a half is 2. And if you want to, this 4x minus 1, because it's minus a half, we can take it down to the bottom line. I'm just going to leave it as power of a half at the moment. So now if we come back to this bit here, y dash. So now this bit differentiates to get this here. We've done that separately. So that now becomes 2 over 4x minus 1 to the power of a half. And our log, to differentiate our log bit, it becomes 1 over that. So 1 over whatever is inside the brackets with it. So it's 4x minus 1 to the power of a half. This is about as hard as it gets. So let's combine it. And what you might see is that these brackets are exactly the same. Now, if we had x to the power of a half times x to the power of a half, sorry, I'm just doing a little side note here. Remember to combine it. We just add our powers together and we'll get x to the power of 1. The same thing happens here. Because they're both 4x minus 1 in the brackets, so we've got a half here and a half here, just add them together and it becomes 4x minus 1 to the power of 1. So the key thing, I guess, with natural logs is that differentiate them inside bit and bring it out the front like we did before. The log then becomes 1 over whatever's inside the brackets. Hopefully that makes sense.